In this video we're going to be going over finding the inverse Laplace transforms involving partial fractions. So I've covered how to do partial fractions in another video, so this would be incorporating both skills. So for this example we have 5s squared plus 3s plus 39 over bracket s squared plus 9 close bracket bracket s minus 2. So we want to split these into partial fractions first. So 5s squared plus 3s plus 39 all divided by s squared plus 9 s minus 2. So we want a over s squared plus 9 and we want b over s minus 2. So if we multiply, if we cross multiply to combine to one fraction, so we have a s minus 2 plus b s squared plus 9 equals 5s squared plus 3s plus 39. So we can make s equal 2. That means this term will be 0. S equals 2. That means this term will be 13. And if we had a calculator, 5, 2 squared plus 3 plus 39, that gives us 65. So B equals 5. Yep. 5, 13, 65, yep. So if we do the same to find out B, we can't unless we use complex numbers, which we don't really need to in this case, so we're just going to put s equals 3. So s equals 3, meaning we'd have 1a. So a plus, so we know b is 5. 3 squared plus 9, because we've substituted s as 3. And then if we put 3 into the other side, we get 93. Put it all on one side. So when we minus this bit from 93, minus 3 squared is 9, 9 plus 9 is 18, times by 5 minus 93, it gives us 90. So we're left with a equals 3. So once we've done that, we've established that we need to find the Laplace transform of 3 over s squared plus 9 plus 5 over s minus 2. Looking at our tables, so we can identify s plus 9. We can also see that this is a square, so this one will be sine. So we have sine 3t, and then 5 s minus 2. So I'm thinking this one is et, because we have we have a single s. So plus 5e to the 2t to the power of 2t. So if we do another example, we have the Laplace of these fractions and we want to split it up. So we want a plus b so if we cross multiply we have a plus b plus 2x minus 1. So if we substitute in x equals 1, this term becomes 0, so we would have minus a equals 1, so a equals minus 1. If we substitute in x equals 3 over 2, so 1.5, this term becomes 0. 1.5 minus 1 is 0.5, and then this term becomes 2, so b equals 4. So we want to find the Laplace transform of minus 1 over x minus 1 plus 4 over 2x minus 3. So looking at the table, so in this case s would equal x. Sorry, I must have wrote x's instead of s's. So we have this one, so minus e to the power of t. And then for this one, 4 over 2e to the minus 3. So we could probably pull 2 out of the bottom. And then that could divide. So then we would have another e. So we have plus, but we can pull the 2 out. 2e to the 1.5t. And that's it. That's how you find the inverse Laplace transforms.